Sound design.
A dropout is just that you've lost enough signal where the squelch engages. So anything that decreases the signal can cause the drop.
Sound design. Sound Design Live is produced independently by me, Nathan Lively, in Minneapolis, Minnesota. Welcome to Sound Design Live, the home of the world's best online training and sound system tuning that you can do at your own pace from anywhere in the world. I'm Nathan Lively, and today I'm joined by touring monitor engineer and RF technician for the Eli Young Band, Stephen Pavlik. Stephen, welcome to Sound Design Live.
Thank you. It's a pleasure to be here.
So, Stephen, how did you get your first job in audio, like your first paying gig?
I was very interested in audio through high school, just playing in bands and kind of had the whole home studio thing. But I guess around junior year when I first got a car, I interviewed all around town, and I got one call back to a pretzel shop in the mall, which didn't take me. And so I decided, screw it. And the closest venue in town was this coffee shop that just had at the time it was hardcore bands. So I went and kind of forced my own internship into there. And then their guy kind of left. And there it was. I started, I think it was like $20 a show, and it was 3 vocal mics and a kick mic, and literally climbed from the bottom.
Wow. So how old were you?
All because the pretzel store didn't get me. 16.
I have a similar story, just to take a quick tangent, that when I first moved to Portugal, I wanted so badly to stay there that after I was there for about 6 months and I still wasn't able to find a job, I was basically going to take any job, and I was applying for jobs at bars. And this is after I'd been to all the recording studios and all the live sound venues. And luckily, none of those bars would take me either because I didn't have any serving experience. So eventually I got a job at a concert venue. So sometimes it's, the rejections that really help us move forward.
It did push you, yeah.
And this coffee shop stayed open late, or they had hardcore shows during the day?
It was a late thing. So they had, I guess, these 2 friends that came in. One was he had a bunch of PA gear. The other was kind of good at booking. And they did a couple shows just outside, and it brought a ton of money. So the coffee shop was like, hey, this is an avenue for, something we could do. So they bought the little strip of real estate. It was a strip center next to them, and opened up a tiny venue that would do shows late at night. And yeah.
I'm just imagining sitting in a Starbucks and then a hardcore band starts.
No. But then there was a coffee shop down the street that tried to copy that model, and they did have a stage in the middle of it, but they were a little more tame with their music choice.
Okay. Cool. So what happened? You came in there, and did you know anyone? Who did you talk to, and how did you force your way into an internship?
I talked to the manager there, and I asked if they have anything like that, and he said no. And I was like, well, how about I just work for free? And they're like, well, why don't you talk to the sound guy there? Okay. Who he wasn't really a sound guy. He just had gear and an interesting way of running it.
He was an equipment owner.
And then eventually, yeah, I mean, he knew enough to make it work, but it was the mains were on aux 1, the monitors were aux 2, and it's why don't you use the mains for the main? It was that kind of thing.
Classic.
It's a little funky. Yeah.
Nice. So how long did you do that?
So about 2 years until I started working legitimately, moved over to Meridian, which was at the time the Live Nation venue in Houston, before House of Blues came in, and they're tied in with all that, so they took over that area.
Cool. So I'm sure a lot of things have happened since then. I'm wondering, was there kind of a turning point at some point where you said, okay, this is not just a hobby anymore, or this is not just about making $20 on a weekend occasionally anymore? When was there a moment when you're like, okay, now this is a real career, or okay, now I know this is what I want to do for the next, significant portion of my life?
Honestly, junior year in high school, I knew I wanted to do it. My girlfriend at the time bought me the Yamaha Sound Reinforcement Handbook.
Whoa, what a great girlfriend.
The Bible at the time, right? And yeah, and again, just fascinated by it. So I definitely knew that was what I wanted to do, and I knew I couldn't stay in the coffee shop thing too long, because you can only go so far with 3 vocal mics and a kick mic and some PV speakers. So a weird thing happened. My mom was a software rep, and she was talking to a guy named Justin Sinclair, who was working at a Best Buy, but he was also in the audio game, and he was working at a club called Fitzgerald's. And I think it was like my 17th birthday. I went out there and just kind of helped him out. Had a GL 2400, and it was, to me at the time, I was like, this is a huge console. And
Sure.
he actually had a whole rack of drummer gear that he brought in because he was pretty obsessed with like just the nicest gear you could have. So there's just, another
That's
tiny crappy club with drummer gates and I think DBX 160s. And it's like, it was fun. And it was just, again, just mesmerized by it all. And he eventually was the one that kind of helped me into Meridian when I actually started making legitimate money and mixing real bands and work with real gear. And then it was...
Isn't it funny how sometimes it's those weak ties of like friends of friends or, family members that end up getting you in somewhere that you never would have thought of to like pursue that avenue. Like, let me talk to my friends of my mom. That's going to help.
Absolutely. And I actually just had lunch with them the other day and we still laugh about it and joke about it.
Awesome.
Yeah, it was my mom that did that one.
See if you could also take kind of now the 20,000 foot view from above, just looking back on everything you've done so far. What's one of the best decisions you made to get more of the work that you really love?
To not be afraid to leave a good thing in hopes of something better.
Oh man, that's so hard, right?
I know, because I feel like there's definitely two schools of thought, which is one of them is loyalty, which I'm really bad about, in a good way, I guess. But
Sure.
And then there's the guys that, and there's nothing wrong with this, but then going to a job and gaining what you can, then leaving and climbing the ladder that way. But if you're the type that sticks around a company long enough or longer, it's definitely an incredibly hard decision to leave in hopes of something better. But in the times I've done it, it's very difficult, but it always has worked out well.
Would you mind taking us to one of those moments for you? Like, what was one of the hardest decisions you had to make to leave for a potential other opportunity that may or may not work out?
The main one, I guess, is I was working at a really just kind of system tech work, which I really enjoyed because I was really into subarrays at the time. And there was a big like staff changeover where it got to the point where it was like, all right, who's staying? And whoever stays, I was one of the first people staying, and they wanted to like make a position where I kind of had more responsibility in a car. And I was like, yeah, I'm in it for the long haul. And, and then maybe, and I got it, but I always wanted to tour. So then I got the touring offer. And then, so after all the whole, I'm in it to win it. Yeah, we're going to do this.
Wow. I'm 100%
then, like, 2
committed.
weeks later,
Nothing will ever change my mind.
Exactly. And then about 2 weeks later, it's like, so about that.
I never thought this would happen. That's tough.
Exactly.
What did they say?
He understood. It was mainly the owner, which we were close, but he gets it. It's people come and go, and they get there and they do their thing, and then they go out on the road, and that's the dream of, I guess, a lot of audio guys. It was mine for the longest time.
And what was that tour that you got offered at that time?
Eli Young, 7 years ago.
Eli Young, and here you are. So how long have you been working with Eli Young?
It's over 7 years.
And so talk a little bit about the band. Who's on stage? What kind of instruments? What kind of inputs are you dealing with?
I'm up to 48 in Monitor World. We have stage right guitar, stage left guitar, keys, bass, tracks, drums, talkbacks, crowds. I like it. It's a four-piece principal, one aux player.
And how many channels of wireless?
With backups, I'm around 23.
And then when you guys are touring, are there also support bands? And then are you working around there? And then are there more channels of wireless on top of that? Are they using yours?
No, they'll bring their own. And I generally coordinate them when I can. If not, dodging them is kind of weird. And there's ways to do it, but it's not really the best for the spectrum. But yeah, so it's more on top of that. I generally try and hit at least 50. Also mainly because the Part 74 license requires that you do a minimum of 50 frequently to hold it, or legally, I guess, or not defraud the FCC in that sense.
Wait, what are you saying? What license?
So there's actually a really good talking point. It's a really good thing called a Part 74 license, which up until recently was only allowed for video production, as far as on scene, on location shooting. But it gives you protection. Right now, everything is what's called a Part 15, which is unlicensed. Basically, you're a secondary service, so you can't cause interference, and you have to accept all interference. With a Part 74, as a licensed user, you still can't necessarily cause interference to a primary, which would be like a TV station for us. But if an unlicensed operator, say an opening band, is turning on transmitters during my show, legally I can shut them down. It gives them the option to operate at 100 and 250 milliwatts, whereas if you're unlicensed, you can only go to 50 milliwatts. And also, we're talking about white space devices, which is what we are, using unused TV channels. You can register within 1 hour. Actually, I think you can register pretty much immediately for protection against newer devices that are coming out, which are using that spectrum for rural internet distribution. Whereas if you're unlicensed, you have to have about, I believe it's 24 to 48 hours, or no, it might be up to a week. You have to register far in advance to get protection from that type of device. So Part 74 license is a really good thing to have, but you have to not necessarily prove, but you have to be honest and use a minimum of 50 channels on a regular basis to qualify for the license.
I see, a minimum of 50 channels. So you're talking about these protections. Can you tell me about how this has played out for you? Or if it hasn't come up yet, how it might play out? What does a protection look like? I mean, are you actually going up to someone else and saying, hey, you're causing interference, I found you, and now I'm turning you off?
Yeah, luckily I haven't had to use the license to do that. Just generally the respect, I guess, or of for lack of better words, the pecking order of a show. So, it's, if I'm in set change, I notice there's a couple transmitters right where I am, and I really don't have time to re-coordinate. That's kind of ridiculous. So I'll go out with a directional antenna and a spectrum analyzer, and I'll find them. And generally, it's just a respect that they'll turn it off. I know that there are some coordinators that do. I mean, I keep my license with me in my work box, but I know there are some guys that have pulled it out and had to go up and be like, look, we need to have some kind of solution. And generally you need to work together. It's not something to abuse, and it's, and two Part 74 license users have to just kind of mitigate the situation with themselves, because if you get the FCC involved, it's going to take weeks, and it's kind of not really, it's not really going to do anything within that.
Sure.
I know I haven't personally had to do that, but it does put some teeth in your bite.
This isn't just some crazy sound engineer coming to bother me like, oh, he's got a license.
But yeah, the other big one, I guess the white space device, we're not seeing a lot of it yet, but Microsoft is very interested in this, and they have, I believe, some patents already where they will distribute high-speed internet over unused devices, unused white space channels, where that's going to be really hard to predict in the future when we're trying to coordinate frequencies. So having that protection, whereas saying that I'm here, so the system, whatever it is, actually has to go through and check this database. And if it sees that, hey, there's somebody that's reserved this because they have wireless microphone channels here, that white space device has to move to a different channel for whatever data it's sending out, which would be usually internet. And so we're going to see that in the future. We don't necessarily know when. I think some of it is in testing already in some campuses, but so that's another good reason to have to get this license if you're eligible for it. Because again, our spectrum is shrinking in more ways than just losing 600 megahertz.
Does that mean that you are basically putting in all the dates of your tour, saying, I'll be at this address, and from this time to this time, I'll be operating on these frequencies, and you have to submit that to a database?
I haven't yet because I haven't run into it. I know a lot of coordinators doing large festivals do. It's actually, you can put it in. There's a couple different websites, but one of them, the big one, is called Spectrum Bridge, where you enter your ID, the channels you're using, and it'll take it or it won't.
Wow. And how do I get this license, and how much is it going to cost me?
The easiest way to do it is through professional wireless systems. It's about $500. The other way, you can file by yourself, but there's about a 90% failure rate with that one.
Oh, wow.
It's a lot of legal documents. But yeah, professional wireless system has a service where it's pretty much guaranteed, as long as you're not like, a felon, or I guess you've they actually do ask if you've had offenses with the FCC before.
Okay,
so
they
if
check your
operated if you've operated a pirate radio station and got caught, you're probably not going to get one. But it's just that kind of thing.
Maybe any challenges that you've had in the last year that you had to find solutions for?
Yeah, the interesting thing about working with that band is that they own all the audio equipment. And
really? Okay.
Yeah, there's a lot of changes that we'll go through that we can't just go back to an audio company and say, well, I want to use this, or I want to switch this out. It's kind of just take it apart, build it, make it work, that kind of thing. So going through the wireless rig with them is really fun because there's just been a lot of changes through the years, and some of it is Band-Aids. Like we switched to a different backline rack, and I have, just it's really not the appropriate way to do this. Kind of just some passive splits with I wired it to where each receiver in this rack had at least one LPDA, but then there's a bunch of dipoles all over the place, which is kind of making an antenna farm. It's absolutely not proper, and we just switched to a different rack, and it doesn't work in this situation. So I did just order on eBay another different antenna distro, which also came with some BNC cables that were not coax, and that's a different story. But be very careful with cheap cables on eBay.
All right, so it's not just like you're speccing a system and saying this is what the band needs, and then it comes out with a rental company. You basically have to take what they have already and make it work with maybe a few minor, like cheaper changes to like Band-Aids, like you said.
Yeah, piece it together, which luckily helps because I have a lot of supplies on hand just at home, and for my company I have a lot of cable and all kinds of stuff to help build those things out cheaply and to get it to where we really are using a professional system, but spec'd or built in a very awkward way to just piece together over time.
Wow. So when you first started with them, was it like barely functional and now you're like pretty happy with it? Or do you feel like you still are not happy with it and you have a lot of changes you want to make?
No, it's great right now. I mean, it was working in the get-go, but it was just, and there's still some weird things going on. There's some definitely ill practices going on, but it does work.
Okay.
Yeah, and actually that's a big one, I think. But for this one, let's say combiners, and I've seen this before. You cannot take, for an antenna combiner, you cannot take the output of an antenna combiner and put it into the input of another one to get more channels, as far as if you want to refer to that as cascading. Mm-hmm. That is horrible. For right now, what's happening is, so we still have old G3, AC3 combiners with PSM 900s into them, which you have to, the PSM 900 goes 10 milliwatts, 50 milliwatts, 100 milliwatts, where the maximum input of the AC3 is 30 milliwatts. So we have to go to 10 milliwatts, but then because I'm using a passive combiner to get the 2 4 channels into one antenna, then I'm losing 3 dB there, then I'm losing 2 dB in cable. So, I mean, do you bump it up to 50 milliwatts and deal with the a little bit of distortion and gain the path? And yeah, generally I do, and you don't see too much from it, but it's not proper practice. So it's just weird things like that.
So you mentioned earlier LPDA and dipole. What are those?
So the LPDA is the shark fin, the paddle antenna, which is a wideband directional antenna. You can almost think of it, when we say directional, as a cardioid pattern, but it generally has about 7 to 9 dBi of gain, which would be passive gain compared to an antenna that's just an omnidirectional radiator. Definitely important to point out that we talk about gain in antennas. It is not active. It's not like an amplifier. It's just saying that I'm not radiating in this direction, so that is actually radiating forward. What would be radiating behind me that's not there is shifted to the forward direction, which is our forward passive gain. So yeah, I definitely have one of those to shoot across the stage. It was important to make sure that one side of each diversity receiver had an antenna with gain. The other side had just a dipole on it in the rack, but because of the rack size and where the antennas were located, it just didn't work as well when we changed racks out. Hence the antenna combiner that we had to eventually buy.
Let's talk a little bit more about wireless then, Stephen. Just to get us started, what is maybe one RF myth that you would like to never hear again?
So I think this one is the one everyone hears and says is that it's black magic or it's voodoo, and it just absolutely
but it is not. Oh God, no. Okay, I get it. Because you're saying it's science, right? Like these are things we can predict.
Absolutely. And like I said, I said this before, but I think the biggest thing about this that everyone just freaks out about is that we have no way of perceiving this. I mean, lighting, you see it. Audio, you can hear it. If you knew nothing about audio, you could walk into a car and say, "Oh, I hear this," or "I hear that."
Right.
Or you can see the video. We have no way of perceiving RF, so we just throw our hands up and go, "Well, I don't know," and that's just not good.
Right.
Yes, you just have to take the time to learn about it, which is fair that some people really don't have that time, and this is a very fast-paced industry, but there's really nothing magical or voodoo about it.
The upside is that maybe that makes your job more valuable since people are so scared of it.
It does. And right now.
But you don't want to be working
yeah.
with colleagues who also feel that way, right?
Right. Yeah, RF coordinators do make a decent amount of money, just because there is a lot behind it that really isn't to deal with audio. And there's even some guys that come in with communications RF degrees that jump into audio, and it's something that's very separate. Whereas whether you're a mix engineer or system tech, you're all dealing within audio. Where you can be just completely an RF tech and jump into it and be like, and not really be familiar with the concert scene at all, but still do your job very efficiently.
So last month you participated in an online summit that I produced. It was called Wireless Workshop, and I thought you did a great presentation. It was called Wireless Crash Course for Monitor Engineers. So one of the most common wireless issues that everyone asked about and wrote in about ahead of time, and I'm sure one of the most common questions you get is how to avoid dropouts. And that's such a difficult question because, as you say at the beginning of your presentation, there's no one solution. So if you could, just answer people and say, well, the way you avoid dropouts is by, painting everything red, and then that would be great. But then I guess people wouldn't be asking that question anymore if it was such a simple solution. So you say in your presentation, there is no one solution. There is no magic box. We need to maximize efficiency and properly deploy every device and step in the chain. Only then can we blame the video guys. So if that's the case, could you help me get started, I guess, by giving me kind of a prioritized checklist of things to look at that can help me track down these wireless dropouts? I'm wondering if maybe we can go through the signal chain, and we could even use your signal chain on the Eli Young band if you want, or look at like a common signal chain, and maybe just with each step look at what are some common pitfalls that could lead to wireless dropouts.
I think we should approach this starting with hardware, and then we need to get into coordination, because that is. I think it's 50% hardware, 50% coordination. Maybe not necessarily that, specific number, but they're both equally important. Yeah. So let's start with the transmitter. Well, let's say IEM. So you're coming out. You need to make sure all your cables are correct. And when I say that, I mean start off with just saying that you're using the right type of cable. There's quite a few times that you'll see video cable involved, 75 ohm, which is a huge debate you can open up within RF techs. Some say absolutely never use it. You will experience some loss due to a mismatch. So you can, but it's not the best. But so let's start off with using the right amount of cable, the right type of cable.
Okay.
And then going back to that reference that I mentioned earlier about that combiner that I just bought. I tested this cable, and it's showing 93 ohms and 3 dB of loss at 12 inches, which is absolutely just unacceptable. So I opened it up, and it's actually a 2-conductor 18-gauge wire that was terminated to BNC. So it's not RF cable at all. It's just somebody bought a bunch of BNC cable bulk and thought, okay, this is workable. And so
did you get your money back?
The problem is a lot of these short cables. Nah, I just wanted the Shure UA844, and it was a really good deal just for that. So I just emailed him and told him that, be careful if you're selling these, these cables to a bunch of people. This is not right.
Oh, wow, that's nice.
Because, I bought it from a seller. Yeah, and so he didn't know either. And,
okay.
It's going back to you kind of have to test coax more than just continuity. But so just making sure you have the right cable. And the easiest way to do that is a lot of times it will be marked on the side. It should say an RG number or whatever the manufacturer is. So make sure you have the right cable. Make sure, another thing to look at is make sure the actual center pin is not extruding past the connector itself. That can happen due to a bad termination, or if the cable slips, but that can eventually damage a BNC port on whatever piece of equipment you're using. So yeah, it kind of starts with making sure right cable for the job.
And the right cable is basically whatever the manufacturer recommends, right? For my transmitter or my receiver.
Sure. And pretty much RG8X or RG8, you'll be fine.
Okay.
When you start screwing off of those numbers, which there's just a plethora of different cables, but that's kind of the most common you're going to see. And and that's referring to an old standard called radio grade. It's still kind of used, but every manufacturer has, their specific cable type or number, but it's usually you can kind of say that it's an 8X or an 8, which is the stuff that 8X would be like this, the thinner cable that Shure sends out. RG8 is the thick stuff that you think of when you think of low loss. So from there, we need to make sure that you're actually wired correctly. Let's say from the IEM perspective, going into the combiner. Again, so an antenna combiner, if you have more than 4 channels, when you have 2 4-channel combiners and you want to use one antenna, you cannot take the output of a combiner and plug it into another one. And the main reason is, again, going into talking about how, let's say, for this example, this I've seen a lot on flight aids as well, with the AC3 Sennheiser combiners. I actually saw one that was 3 of them daisy chained together. But what we have to think about is that's 4 30 milliwatt inputs. So you're dealing with, the 120 milliwatts. Now, necessarily not all of them will combine at once factorially to cause 120 milliwatts, but it will happen. And then you're putting that to a 30 milliwatt input, and that's a substantial overload. So that's the reason we don't want to do that. And I've seen that so many times. If you want to combine 2 active combiners, you have to use a passive combiner, like a Wilkinson power divider, that can take that. So that's a big one. Mm-hmm. So do not cascade active antenna combiners. From there, you go out to your antenna, and you just make sure your antenna is in a good location. Line of sight is very, very much key. RF does propagate through walls and reflects all over the place, but your direct line of sight is your best bet. Make sure your antenna is not close to metal, and not close to power, and that's kind of on the transmit side. And now combiners do go bad as well, and that's kind of where it's really, really handy to have a spectrum analyzer. We were just out with Andy Grammer on a flight date with them, and they were having issues. They had a PSM 1000 system, and we were using 900s, and it was a 4-channel combiner, and the actual combiner was just putting out a lower output than it should have. Mm-hmm. And it was causing dropouts.
Wow, so just a slightly lower output, and that was low enough to make it drop out. Okay.
Oh, absolutely, yeah. I mean, really all we're doing is trying to maximize signal through the wireless link to the receiver. I think, actually, let me go back to that. A dropout, all a dropout is you have a low enough signal that the squelch engages. So if you're dropping out, you've lost signal for some reason, whether it's through your transmission system, or maybe you're seeing some sort of interference that the receiver is actually kind of jumping, maybe FM capture effect, trying to jump to a different channel, or that interference signal just suppresses it enough to engage the squelch. A dropout is just that you've lost enough signal where the squelch engages. So anything that decreases the signal can cause the drop. And going back to combiners, I've seen a lot of the Shure, the PA821s or 421s, they might lose actually just one output or one input. I've seen just one input on the combiner go bad. So only one frequency is bad. The rest of the combiner works, which is actually pretty tricky to locate, but that does happen. And sometimes entire combiners fail. And that's kind of tricky to see without a spectrum analyzer. You can eventually track it down just by walking around with packs and figuring out that, hey, these 4 packs, no matter what frequency I use, are not working. Mm-hmm. But it's also easier just to see maybe this 4-channel combiner compared to this 4-channel combiner on a spectrum analyzer and say, these 4 channels are significantly lower across the board. And, so anything can fail. It's definitely don't rule anything out. And transmitters fail sometimes. They just won't output that frequency. You see it more in microphones and body packs, but the rack mount ones will do that as well. So as far as the hardware side, I think for IEM at least, that's kind of it. Now, if we talk about the transmitter for a microphone, really not much that can happen there. It works or it doesn't. Now, for a body pack, another one I see a lot, let's say you have a Shure Electrosonics where you have an SMA connector for the antenna. Mm-hmm. They have a little locking nut on them. And sometimes that rolls back a little bit, and so you don't have a good connection to the antenna. And I've seen drops happen because of this.
Oh, wow.
Yeah, and so if you're looking at your diversity receiver, if you see both A and B signals go down at the same time, then you have a problem with the actual signal getting to the receiver. It's not one antenna or the other. If not, you'd see one side drop, the other stay constant. Mm-hmm. And so I've seen this a lot on guitar packs, is where that washer, that nut backs up a little bit, and so the antenna doesn't get a firm connection in there.
On the transmitter itself, right?
Just lose signal. Yes, on the body pack transmitter. So you have to go there, take the antenna off, tighten that nut down, then tighten the antenna back on, and it's totally fine.
Wow. Okay. So we've talked about several different points in the signal chain here, but my biggest takeaway so far is that what a dropout is low enough signal that it goes below some threshold where the squelch engages, wherever you have your squelch set, right? And
yes,
that signal attenuation can be caused by a lot of different things. And basically every point in the signal chain has some effect on the signal level. And so we have to take care to make sure that we're maintaining that signal level within whatever the operational parameters are, right? Because if it goes too low, it engages the squelch. If it goes too high, we have overloads.
Absolutely.
Okay.
Yeah, it's really just maximizing gain to the transmitter, or from the transmitter to the receiver. And I know we talked about this in the wireless workshop, but the most loss you're going to see is in that wireless path. It is important to know how much cable loss you have, because that's, again, we're trying to maximize signal. So if you're running 200 feet of cable that's with nothing, for trying to get a signal out from maybe a transmit, you're going to lose maybe 5, 6, 7 dB. But if you go 30 feet, you're going to lose maybe 30 dB wirelessly. So you really just need to pay attention to all your gains and losses.
Stephen, I want to I'm sure you have done this, but I wanted to share an aha moment that I had at a Shure training workshop earlier this year. So they had some kind of spectrum analyzer there, and they were just basically showing us the level coming in from a transmitter. And all they did was take the transmitter pack and move it from in front of their body to behind their body, so that their body was in between the transmitter and the receiver. And you see this huge decrease in signal level, and it was like terrifying. And it was such a good moment for me, because I had heard that you should make sure that you have line of sight, and I've always heard about that, but I was like, it can't be that much, right? Like, the microphone still works. But now it's so clear to me that I need to, as much as possible, try to make sure that I place transmitters, if I'm placing them on a human, if I place them so that they will be without obstruction as much as possible to the antenna. So if the antenna is behind the stage, it's good to put it on, the back of someone, the transmitter. And if the antennas are somewhere in front of the stage or at front of house, then I would try and put the transmitter, on the front or the side of a person. So just to not have that human body obstructing it, because these bags of water are one of the biggest problems, right?
Oh, absolutely. Yeah. Body absorption is huge. It's one of those things that's it's hard to measure, but I know a buddy of mine did some tests, and I think he found up to, with the antenna touching the skin, or at least grabbing around the bottom of a mic where the antenna would be, you can get up to 90 dB of attenuation. Yeah, so line of sight is huge. And also with that one, just try to make sure the antenna, either if it's a whip antenna from a body pack, or if someone's grabbing the microphone, that the antenna doesn't touch skin, because that'll also take out another 20 dB.
And I don't know if you shared this tip or someone else did at the wireless workshop, maybe multiple people did, but putting a plastic straw on the antenna sounded like a really smart, easy way to get the antenna, make sure the antenna is not going to touch skin.
Yeah, I have heard that, and also it'll keep it straight, because a lot of the antennas do sag a little bit, or over time they just kind of get bent to one direction or another.
This is another thing I never understood until wireless workshop. I was so surprised. Someone asked, because they were you and some other people were talking about the orientation, because these antennas and the transmitter and receiving antennas have a polar pattern, and they need to be aligned for proper reception. And so, if the antenna gets bent at all, which happens a lot, when we're putting transmitters on humans and they're getting moved around and there's clothes and stuff, then that's going to change the way it transmits, right? And I don't know how much loss would be experienced. I don't know. Do you want to say anything else about what happens when you bend an antenna?
So bending and or just having it 90 degrees off of, let's say that you're you have maybe you're holding your microphone vertically and the antenna's vertically polarized or oriented, and that's great. You should have maximum signal transfer. But if you go 90 degrees off of that, so I'm holding my microphone horizontally and the antenna is vertical, this is where it gets tricky, because theoretically you would have an infinite amount of loss, which if you're an anechoic chamber for RF, that may be true. But because we have so many reflections in our environment, and each time RF reflects off of something, it kind of bends the wave a little bit in its polarization, that we don't necessarily see that infinite amount of loss, but you do see generally maybe 10 dB, 10, 12, and that's a very rough number because it could be anything, but you do definitely see that loss. Not enough to just completely make it disappear, but it does affect very much so, which is why, again, there's a lot of interest in circular polarized antennas, which right now is the helical antenna.
The helical antenna. Okay, this is one thing I didn't know about also until recently. This is fun because so much of this is brand new for me. Okay, I think the most common helical antenna that people will recognize that they've either seen on shows or seen photos of is because it's funny looking. It's it looks like clear plastic and has like a circular tube on the front. So it's like a big round disc with a tube on the front, right?
Yep, big old corkscrew looking thing.
And that is ultra directional, right? So that's even more directional and focused than an LPDA.
Absolutely, which is a blessing and a curse. They do make different kinds. So the one that everyone's familiar with, the professional wireless, the 8089, has a 60 degree beam width. Kind of imagine that if you're looking at the beam, it's 60 degrees wide. Mm-hmm. Which means it has a very high directional gain, because if we have 60 degrees there, then all the gain that will be radiating out behind it is focused forward, which kind of gives them about 12 to 14 dBi is what they spec. Now, they have some that just look like domes, and Sennheiser has kind of the big one, the A5000 something. And now that one, I believe, is 80 degree beam width, and then is just as much. Yeah, that one's 80 degrees. I think Professional Wireless System has a dome that's 80 degrees as well. So you have a little bit less forward gain, but you do have a little bit wider of a spread, which is really nice. And you still have that circular polarization. The RF Venue, the collapsing ones, I think are around 70 degrees, but don't quote me on that because I don't exactly remember. But yeah, so the problem with that is that they get incredibly directional. Now, but you have to remember that they also follow inverse square law. So as you're radiating forward, you're radiating out. So that doesn't mean it's locked into just 60 degrees. It's definitely radiating all around when it coms out, but you do have your main power within that 60 degrees.
I see. So if a standard like Shure Shark Fin LPDA has, a coverage angle of something like 120 degrees, that's still wide enough that I can kind of just put it up and point it in the direction of the stage, point it in the direction of the talent, wherever I think the transmitters are going to be. But when you get to, half as wide at 60 degrees, that now requires a little bit more focus, and you can't be so haphazard. You really have to have it pointed in the right direction.
Absolutely. And in some weird situations where the stage is very awkwardly shaped, and I'm just going to throw out Billy Bob's in Fort Worth.
What's going on with the stage at Billy Bob's?
There's a very tall section that has the main stage and lighting, and then it kind of comes down to a roof that's about maybe 7 foot tall, where there's still performance space on either side.
Wow.
And so when you have a bass player underneath this roof with pipes and all kinds of metal that RF doesn't like, literally moving that helical a couple inches actually got coverage over there. So it's,
wow, scary.
A tighter beam width means just a little more planning on where you're pointing it.
Anything else on your mind that you would want to share with people in terms of troubleshooting their own dropout problems they're having?
Actually, real quick, going into receivers, the diversity receiver, looking at the front of it is a really good way of, troubleshooting. If you see both meters drop, there's a problem with the signal coming into it. If you see one side dropping consistently, there might be a problem with that cable or that antenna. It could be a multipath, but if it's a consistent drop, you definitely need to look at that side. But again, if you see both sides drop at the same time, there's probably a problem with your transmitter getting to receiver. It's harder to tell an IEM. Now, there's also the interference with coordination, which if you're not coordinating with software like Wireless Workbench or Wireless Management or IAS, you do need to keep everything in the same group. If not, intermod is huge for us, which can cause drops because that intermod is going to get in within the channel filtering. of the receiver. Whereas let's say that if you had frequencies spaced maybe 400, but let's say 500 kilohertz away, the channel filter can take that out. But if it creates an intermod, that can get inside the filter, and that can cause problems. So if you're coordinating only on the equipment you're using, you need to try and find a group that has the most open channels and get everything within a channel that's in that group, because the manufacturers pre-coordinate these. If you're doing it with software, you need to be very careful about what you're letting the software decide for you. And I've mentioned this before, but be very careful with the exclusion threshold on Workbench, because if it's set too high, it'll definitely put your channel too close to or on top of things that it doesn't need to be on, like TV channels. And all of these things can cause dropouts as well. So the signal competing for, with an interference can cause that to drop below the squelch level and cause a drop.
One more thing I'm going to say about troubleshooting, because someone posted about this on Facebook recently. What I suggested to them was to start by just drawing out their entire signal path so that they're not, just trying to do everything from their own imagination. It's hard to keep all these details in your mind at once. So draw it out like in a diagram or a list, however you want to do it, your entire signal path. And then for each point in the signal chain there, try to list as many problems as you think could go wrong there, or things you could test. And then you can kind of go through it one by one. Otherwise, I think troubleshooting a complex system like that, just on your own, like, let's try turning it on, turning it off again, turning it on again. Let's see if that works. Then then you do 5 tests, and then you forgot what the first one was. And it can be hard to do without a plan.
Saves you from, maybe just, having to repeat the same test over again because you forgot something or...
Tell us about the biggest or maybe most painful mistake you've made on the job and how you recovered.
This one has to deal with power and sparks.
Oh, wow.
We were doing a festival in Steamboat Springs, Colorado, which gets incredibly cold, and I think it was about -10 this day. And one of the generators seized up because the diesel froze.
Oh my God.
No matter how much diesel conditioner you put in, it's just it's cold. We had to switch to an emergency generator, or backup, I should say. So we powered down audio distro. I thought lighting was powered down. Anyway, so if I don't remember why, but for some reason, the only tails I had to switch over to this generator had a European color code, and which I didn't know. I knew the colors were wrong, but I didn't know what that it was supposed to be. So I kind of just in my head thought, well, maybe I'll just match these colors as closely as I can to American.
Wow, so a European generator just happened to be there, and so you have these cam lock connectors in your hands, and that's what you're trying to connect them to.
Oh no, it was an American generator, but it was a European color code, which has browns and oranges. It's not the black, red, blue, green, white for tails. And so I was just trying to say, well, this color looks like that color, so we're going to make this neutral, and this color looks like that color, so we're going to make this ground, and then we'll meter it at the distro because it's like blizzard conditions. Bad visibility and a parka trying to tie a generator in.
Oh, I get it. You're outside trying to handle this because the generator's outside. Okay, this makes sense.
Yeah. And so I'm just trying to kind of make the colors work in my head. I guess a neutral and a hot got crossed because I flipped the switch and then you just hear screams from inside the tank.
Oh my God.
And so I turned off real quick. And so what happened was, within that, I guess the hot hitting the neutral, it blew all the pass-throughs on a bunch of Mac 101s on the upstage truss.
Wow. Wait, a Mac 101's a lighting instrument?
That's a little moving head wash.
Okay.
And they thought we blew up, they thought I blew up all the lights. And word spread real quick around the town that the tent was on fire and all this good stuff.
Was it?
It turns out it was just the actual, they all popped instantly and sparks went everywhere.
Okay.
But it was just the pass through. It was the actual power con out that broke. So everything was fine. But yeah,
everything was fine. No big deal. Why is everyone freaking out?
There's something about throwing a big old power switch and hearing screaming and popping, and
Oh man, that's terrifying.
That was not good.
So, I mean,
Yeah.
you didn't really learn anything because you're just like, well, the colors. I hope that never happens again.
Well, I learned not to just be so lax with trying to quickly troubleshoot a power system.
Oh, make sure everything was powered down, right?
Yeah, that was true too. Audio is powered down. Hey,
Oh, wow, that's amazing. Stephen, will you talk a little bit about what's in your work bag? I'm sure you have a lot of good stuff in there, but are there a few pieces you could share with us that you think are most important, or maybe you think are unique that other people might not know about?
the Pelican has my main spectrum analyzer, a bag full of connectors, all kind of adapters you could ever imagine. I definitely carry two Wilkinson power dividers, which is, you can think of it as a splitter, but it can actually take power as opposed to, let's say, a resistive split like the UA221s. You don't really want to put power into that. And so those are just universal RF splits, which can be used in any situation, transmit or receive. So I carry two of those and use them frequently on flight aids. I carry two 4-pole cavity filters.
What is that?
So a lot of the filters you see on the market have a fixed start and stop, or a fixed pass band, which let's say might be 470 megahertz to maybe 570. A cavity filter is just kind of what it sounds like. It's an empty cavity with a pole, a screw in it, a pole in it, and depending on how far the screw is what frequency is resonant to. And so you can get a nice steep filter that you can retune on site.
This is an adjustable filter for
yes,
RF coming in.
It's a tunable filter. Okay. Now, generally, these filters are a tighter of a bandwidth. They're going to be, you kind of order them to like a TV channel. Most of mine that I have in my little office/shop are 6 megahertz. This one is the smallest one I have, so it fits in my bag really well, but it's 8 megahertz, which is fine. And so I do carry a tunable filter with me. I've only had to bust them out a couple times because of just really bad environments. But you can get a really steep, nice pass band that you can tune anywhere. But to do that, you need some sort of 2-port analyzer. So I carry a cheap network analyzer that's handheld, battery powered. It's actually made for hams, called a KC901S. Ham is an amateur radio operators, but it really is a cool device because it can do antenna measurements. Its single port measurement, which would be an S11, which is a reflection measurement, is vector, so you can see phase. The 2-port is scalar, which means you're only looking at amplitude over frequency, but that's really all you need to do to tune a filter or check to do a different type of test on a coax. But it's a really cool device. It also has RF signal generator, has an insertion loss meter. It's just kind of an RF multimeter type tool thing.
Wait, so the difference between spectrum analyzer and network analyzer is that spectrum's measuring RF in the air and network analyzer is measuring pieces of hardware like cables?
Kind of. So a spectrum analyzer is only going to take an input and break it down over frequency and an amplitude. So a network analyzer is just what it sounds like. It's measuring a network. It's measuring multiple things. So you can make a network analyzer out of a spectrum analyzer if you have something called a tracking generator, which is what this 2-port measurement does. And you can think of that, a tracking generator is almost like the pink noise to your RTA or your smart, and the spectrum analyzer is your RTA or your smart. So what it does is, let's say the 2-port on this network analyzer is it just sends RF noise across the entire spectrum, and there's an analyzer that tracks it, and it can lay down a trace to show you the response of this instrument or whatever you're measuring, which would be network analysis. It's 2 ports. Mm-hmm. So a spectrum analyzer is essentially a part of that, but it's built into this one unit.
And what is the spectrum analyzer that you carry with you?
I carry the TTI PSA 2702, and as my backup, I carry the Signal Hound SA44B, which is a PC-based analyzer. I definitely carry as many antennas as I can fit in there. I always carry 2 Sennheiser A1031Us. I carry a Professional Wireless Systems LPDA and 2 Lectrosonics SNA 600s. Just for whatever you might need to. And I use the 1031 for a scan, and then again on flight aids, I'm always rewiring RF rigs because it is just amazing how many weird things people do to RF rigs that it just, a lot of these flight aids I would not get by on without this workbox I carry with me. No matter how much you advance and spec it out, people just do weird things with RF rigs.
Right, because as we just described, most people still think it's black magic. Or I should stop that. I'm supporting the myth. A lot of people still think it's black magic. And one of the results of that is that people do weird things with their rigs. So you have to travel with 5 different antennas.
Yeah, it's funny because there's times I'm like, man, we're traveling with too many cases this time. I should just leave this behind, but I carry it anyway, and that's of course the time that I rewire everything.
Of course.
And I actually do carry with me a battery-powered antenna distro that's usually used for motion or on-site ENG type things, but actually have had to wind up using that for the first time really in Korea when they just cascaded I think like 15 UHFR receivers. And just real quick, while they do have cascade ports on them, each time you cascade, you actually kind of shrink the band that you're working in due to something called filter ripple. And so when you cascade that many, you have to imagine almost as an upside down triangle where the top units, you can go far out in frequency, but the lower you go, you need to make sure your frequencies are tighter in the center. Again, it's hard to explain. You have to kind of get into filtering at that point, but you will start kind of bringing in the passband and shrinking it down each time you cascade. And they cascade like 15 of them, and they use like 100-foot cables on each one, so you have an incredible amount of loss. And like, it was just all over the place. So I decided nope, and I just brought out my battery-powered antenna distro and just used that instead.
All right, and do you know the model of that offhand?
It's a PSC RF Multi. You can find them on eBay for about $50 here and there.
Cool. That would also be great, I think, for those of us who just end up in places where there's no distro, and so you're either going to have an antenna farm, or I guess if you've got your own battery-powered antenna distro with you, that would be another solution.
Yeah, that's really the reason I have with me, just whenever you run into that situation.
Stephen, what is one book that has been immensely helpful to you?
For audio, definitely, it was written in the 80s, but I still swear by the Yamaha sound reinforcement handbook.
Wow. Maybe I should look at it again, because when you were talking about it, I was like, yeah, I looked at that in high school as well. I didn't understand any of it. I just remember the diagram explaining microphone feedback, and that was really helpful. But okay, you're making me want to go back and look at it again.
As far as getting into RF, the first book I picked up was the ARRL Antenna Handbook. That one kind of dives into some stuff that really isn't happening in our fields, because when you're talking about antennas that go down to 20 megahertz or even in the kilohertz, you deal with a lot more like environmental ground and height above ground and stuff that we don't necessarily deal with as much with low power UHF stuff. But that's a really, really good one. The Secrets of RF Circuit Design is another good one. It actually approaches RF with very little physics and just kind of gets you the building blocks without diving too heavily in the math, because unfortunately a lot of it is very physics heavy. We're in a very weird space where you kind of are grabbing from everywhere, from hams to the microwave guys. There's not a lot of books out there that just really say, hey, you're operating wireless microphones in UHF spectrum, here's how to do it. That there's not a whole book or manual written about that. It's, you kind of grab from it. RF is RF, so it's all the same principles, but just you have to make it apply to you while bringing in from a book about RF at 24 gigahertz, or maybe a book about this is two-way communication at 147 or whatever, and then just kind of take all of that and bring it into UHF where you're working at, because most UHF is broadcast.
Tell me about what you're listening to.
This Week in Radio Tech.
Okay.
That is my favorite one so far.
Really? That's a podcast. Awesome.
Yeah, it is. And it mainly focuses on broadcast for FM, which is actually really great, though, because a lot of our systems still are FM. Again, they're kind of dealing with different things. They're dealing with transmitters. Or definitely have different building blocks using exciters, and they're trying to get it broadcast out, to cars and just radio. But they definitely bring in radio engineers down, and they talk about it. It's really interesting. I do follow that one religiously.
Where's the best place for people to follow your work?
Sventenna.com.
Well, Stephen, thank you so much for joining me on Sound Design Live.
Yeah, this is fun.
Sound Design Live. I really learned a lot in having this conversation with Stephen, so much so that I have asked him to produce a new pilot course with me. It's called Real World RF Troubleshooting, and we'll be announcing it in about a week or a week and a half through email. So keep an eye on your email to get all of the details about that. All the music in today's episode is by Steve Knotts. You can and should find all of his music over at soundcloud.com/Steve Knotts. That's STEVKNOTS. Sound Design Live is supported by Learn Stage Lighting, Scott, Pedro, Ryan, Bob, Martin, Roadie Free Radio, Joel, Ellis, Jem, Senqui, Nicholas, Kuba, Chris, DC Sound Op, and Dave. You can start supporting Sound Design Live for as little as $1 today over at patreon.com/sounddesignlive.